Okay, Bismillahirrahmanirrahim. Welcome back to our session. Um, we have gone through the one example for sample size less than 10, remember? So for this section, what we will do will be we will continue to to our discussion on the sample size less than 10, but earlier was for manual calculation. So now we want to share how to run this data on SPSS, and then later on how to run this on SLT. And then after we have done that, we go for another example where we have more than 10 or more. Then we go for the manual calculation and then proceed to SPSS and finally SLT. So that is what we intend to do in our second half. To make sure everyone, please open your SPSS, and we want to enter our data. We want to run our data on SPSS for sample size less than 10. But just as a reminder, when we run for this Spearman row correlation, as what we did earlier for other statistic, the rest of the statistic, the value for manual calculation and the value that we get for SPSS will be the same, identical, similar. But unfortunately, when we run for Spearman row, the value is slightly different. The value that we get from SPSS is slightly different. Remember, when we did the manual calculation, RS was 0.254. Is that right? RS was 0.254. But when you run for our SPSS, the value will not be exactly 0.254, will differ slightly, because I'm not sure, maybe SPSS, they are using different formula to calculate for the RS. But the one that we use, the formula that we use, which was RS equal 1 minus 6 summation D square divided by N square minus 1, that is the formula that that are used widely in textbook. So I mean, we stick to that formula, but what we should expect will be when we run for SPSS, don't be surprised that the value will be different. But the difference is not that much. Normally, the interpretation will also be within the range. Earlier, when we calculate 0.254, what we see in terms of the nature of relationship, we see there is a positive and low relationship, right? So when we when we derive our RS from SPSS, the result will be the same. That means still positive, still low, right? And then when we go for our manual calculation, when we test for the hypothesis, we fail to reject the null hypothesis, right? When we go for SPSS, the result will also be the same. That means we will also fail to reject the null hypothesis. But I just want to caution here that when you run for your SPSS, the value that we get will be slightly different, right? Okay, now let's go for our SPSS for this purpose. Let me copy the data set first. The data set that we used earlier. Okay, let me copy data set. Okay, now everyone please open your SPSS. Open SPSS. Have I record? Yeah, already record. SPSS. Okay, SPSS is here. Okay, now since I copy the data, so I just paste into the data editor, the data view. All right, so I remove this 2 column. And then, okay, now first of all, click on variable view, define as X, the first variable as X, the second variable as Y. What is X? X is loyalty score, loyalty, and then Y will be performance. Performance. Okay, that are the 2 variables, X, loyalty, Y, performance. Or maybe you want to put scores here. And loyalty will be loyalty score. So, okay, and then once we have defined the 2 variables as Y and X, loyalty scores and performance scores, and then click on data view. Okay, please enter the data as on the screen where we have 9 cases into your SPSS. So in this case, if you observe, the sample size is less than 10. Sample size is less than 10. Okay, for manual calculation, that means we use the first procedure in our testing for hypothesis. Okay, everyone, have you entered the data set? Data for X, data for Y, score for X, score for Y. Anybody still need extra time? Otherwise, okay, how to run this in SPSS? Click on Analyze, click on Analyze, click on Correlate, and then click on Bivariate. Analyze, correlate, and on the right, bivariate. What do you mean by bi? Bi here refer to two variable. That means correlation between two variable. So now once you click on bivariate, simply enter X and Y into the right box, into the variable box on the right. And if you observe under correlation coefficient, by default, Pearson is ticked. That means by default, Pearson is selected, but we are not interested in Pearson for the moment. So tick on Spearman rule, the last option. That means we can just simply tick. We don't have to do the calculation. Tick option for Spearman rule, Spearman correlation. And then you see here, test of significance, we have the option. As compared to in t-test, we don't have the option for one tail or two tail, is that right? But here we have the option. Whether you want to go for two tail by default, or you can change to one tail. In our case, are we testing for one tail or two tail? Latifah, we test for one tail or two tail? In our example just now?
One tail.
Ya ke? Mentang-mentang tengok kucing kat sebelah tu ada one tail, bukan? Kita test for two tail, remember? Because the statement doesn't indicate direction, therefore it call for two tail. So sebenarnya sebab saya nampak kat sini pun apa ni Latifah tu macam gelap sikit, apa ni tak cukup kan, tak cukup cahaya. So kena tambah cahaya. Okay, so by default it's two tail, so you just maintain, and then once done, simply click on OK. Once you click OK, then you get this dialog box. This result in the SPSS viewer. Let me change my screen to viewer. Okay, this is our result here. You are given here non-parametric correlation. You need to observe this because why? Later on, if let's say in the exam, I give you the result for this analysis, you need to differentiate between Spearman and Pearson correlation. So for Spearman, it indicates in the title as non-parametric correlation. I mean non-parametric correlation. I mean this is Spearman row correlation. And how do you know that this is Spearman row? If you go to the table, it is also listed here Spearman row. See? I mean this indicate that this is result for Spearman row correlation coefficient analysis, not Pearson. Later on next week when we go for Pearson, then you can see the difference. You can see the difference because the pattern will be pretty much the same. You are given the table and then you are given the title, but how to differentiate? You look at the title. The title in this case is non-parametric, and in the table it indicates Spearman row. Okay, now if we when we work on your one-way analysis of variant, we work on a table. A table. What do you call that table? When we work on one-way analysis of variant, what do you call that table that we prepare? We have the source, sum square, degree of freedom, mean square, and F. What do you call that table? Nabila nak betul tapi tengkuk dulu baru. Okay, what do you call that table? In ANOVA,
table.
do you call that table as summary ANOVA table? That's right. And then last week, we work on chi-square, is that right? We also are working on using one table where we have the observe, expected, observe minus expected square, and observe minus expected square divided by expected. What do you call that table?
Contingency.
This will be a possible question in part 1 for the final exam. In ANOVA, you call that table as summary ANOVA table. In chi-square, we also work using a table. We work on a table. And what do you call that table where you have your O minus E square, O minus E square divided by expected? Yeah, anybody? Last week, not so long.
Contingency, no? Contingency.
Huh?
Contingency.
Yes, that table is called
Contingency, yeah.
contingency table.
Contingency.
Okay, now, when you run for your SPSS, for Spearman row, as well as for next week, Pearson correlation, you are given this table. What do you call this table? What do you call this table?
Correlation.
Correlation table.
Incomplete, not just correlation table.
Correlation matrix table.
That's right. Apa ini, Samsu, your answer is perfect. This table is called correlation matrix table, MATRIX, correlation matrix table, whereby when you look at the correlation matrix table, the value in the diagonal will always be 1. If you expand this table, let's say 3 by 3 or 4 by 4 or 6 by 6, then the value in the diagonal will always be 1. In each of these compartment or cell, you have here 3 value: correlation coefficient, significant to tail, and n. That means in this case, the first value reported as 0.218 is your RS. The second value is, this RS, the second value is your P, significant value for the RS, and 9 here refer to sample size. And the value on the upper portion and the lower portion will be the same. And that's why we call this as correlation matrix table. The value on the diagonal will always be 1. Why? Okay, the reason is, Mahfuz, why the value in the diagonal, the RS will always be 1? Why?
Because there's a relationship between the two.
Yeah, relationship between the same variables, yeah, right? In this case, loyalty and loyalty, of course, perfect relationship. Here, loyalty. That means you get 1.0, the RS, which is perfect relationships, yeah, right? And then another one here will be here, which is performance and performance. That's why we have the diagonal. The value for the coefficient will always be 1. Why 1? Because these are correlation between same variable. But what we're interested is to look at the RS between IV and DV. So in this case, we have only one value, which is this case between loyalty and performance, which is 0.218, or you can refer to this portion here, performance and loyalty, which is 0.218, right? Okay, so that will be the value that we get. Okay, now, if you are given this output in your exam, what are the possible questions that you may be asked that you need to know, you need to answer? Okay, let me try to come up with the possible question. Question number 1. Okay, I'll give you question number 1. Question number 1, what are the variables involved in this analysis? What are the variables involved in this analysis? Anybody want to respond? What are the variables involved in this analysis? Mahfuz duk ganggu je apa jawapannya.
Loyalty and performance. Loyalty score, performance score.
Loyalty and performance. Okay, that's right. Okay, question number 1 done. Nampak tak mudah je. Okay, question number 2. If you were to test the hypothesis on relationship between these two variables at 0.05, question number tadi question 2, but A, what would be the appropriate null and alternative hypothesis? Okay, like I said, the question number 2, the general question number 2 is, if you were to test this hypothesis on the relationship between the two variables at 0.05 level of significance, A, what would be HO and HA? Anybody want to respond? What should be HO and HA? Anybody?
There is a relationship between loyalty score and performance
that
score.
one, if you want to write in your thesis or in your project paper. But here, for subject, that we put in symbol form. So HO, rho S equals 0.
Rho S equals 0.
That's right. HA, because it doesn't indicate direction, because after all here, it indicates two tail, is it right? Significant two tail. Therefore, HA, rho S not equal to 0. That is A. B, what would be the alpha set in this analysis? What should be the alpha set in this analysis? What is the confidence level for this analysis? How come nama Aisyah tapi muka apa ini Najib? Latifah betul, Mahfuz betul, Syahnan betul tapi nama baru tukar. Mengapa tu? Okey tak apa. Okey, Najib nak cuba? B, what would be the significant level set for this analysis?
The alpha. The significant level 0.05 lah.
Yeah, alpha equal 0.05. B. C. Okay, ada 4 more coming in. Okay, C. What would be the value for the test statistic? What would be the value for the test statistic? Okay, that will be C. What would be the value for the test statistic?
0.572.
Pardon me? Point?
572.
No. What would be the value for the test statistic? That is the P value. The test statistic here will be your RS, remember?
ORS. 0.2.
So, if you just write 0.218, that is partial answer. You should write as RS equal 0.218. That will be the full the complete answer. I mean, if the question asks what would be the value for the test statistic, I mean we need to declare what is the test statistic, the symbol, and what is the value. So in this case, RS equal 0.218. C. D. What would be your decision and justify your answer? What would be your decision and justify your answer?
Reject.
Reject or free to reject? Why?
Free to reject.
Okay, why?
Sigma value 0.57A bigger than 0 alpha.
Okay, so then since significant RS within bracket 0.572 bigger than alpha within bracket 0.05, therefore fail to reject null hypothesis. I mean our decision is fail to reject. Justification is significant RS bigger than alpha, but you need to indicate the value so that we can see clearly which value that you are referring to. You are not referring to 0.218, you are referring to 0.572. And for the alpha, you are referring the alpha to be 0.05. Okay, that will be step number 4. D. Question number D. Question E. Question 2E. What can you conclude based on the above hypothesis test? What would be your conclusion based on the above hypothesis test? So what can we conclude?
There is
no significant relationship.
Sambung lagi, that is incomplete. Between
loyalty and performance.
Yes, at
0.05 level of
0.05 level of
significance.
significance. That will be a complete answer. I mean, the conclusion will be, since we fail to reject, we conclude there is no significant relationship between what? Between loyalty and performance. At what alpha? At 0.05 level of significance. That will be what I expect for your complete answer. Right? But of course, if you want to write in your thesis, in your project paper, based on APA, then we can refer to the notes. I mean, how we present the result, so that we abide to the APA style. But for our answer, suffice for you to say that since we fail to reject the null hypothesis, then there is no significant relationship between the two variables, which are loyalty and performance at 0.05 level of significance. Then take care for the possible question to be asked if you are given this output, right? Okay, so next, the same mapping data, we share how to run this in SPSS, in SLT. Okay, let's copy the data set first. The data set, copy the data, so you don't have to rewrite, to just copy X and Y. Okay, let me go to this one here. Go to your SPSS data editor, the data view, go to the data view, and then just simply copy this. Copy this to this data set, Control C, or just simply click the right button and then copy. And then now open your SLT. Open your SLT. Let me open my SLT. And then open SLT for Spearman row option 15, Spearman row RS, Spearman row correlation RS. The next option will be if your sample size is more than or equal to 10. So in this case, we go for this one, for this, and then just paste your data here. When you paste your data, then automatically it derives the Rx, Ry. That means it ranks for the X, rank for the Y, and then it calculate for you the D, and also calculate for the D square. And what we want is summation D square, right? So summation D square is given here, which is 89.5. I mean, when you do your calculation for your assignment, you can check your calculation here. Because when you run for SPSS, it doesn't show, is it right? But here, it shows how you derive your Rx, Ry, D square, and the value for summation D square. Naziha tak payah kerut dahi tu. Relax. After all benda tahu, everyone have your opinion. Okay, by the way, those who have been working on SLT for the last topic, which is chi-square, did you experience any problem when you enter data from assignment 1 into SLT1? Do you get the result? Or you didn't try? Because you just run SPSS, right? Anybody have tried how to copy data? Let's say we run gender and participation cat, and then we copy and paste into SLT1 for that two variable. Do you get the result?
If you use chi-square data, they have error.
Error kan? Okay. So somebody have mentioned to me from the other class, the other group, which is group section 3. So what I did yesterday, I have already made the alteration. So I will share through this group the new updated version afterward. And for those, by right, only for those who have bought the SLT1, you can download the new updated version. But for those who don't buy the app earlier, so you can just look at the SLT by right. I'm not talking about by wrong, because sometimes people go by wrong, right? So by right, for those who have already bought the SLT1, then once I upload the new version, I put as version 2021, and you can try to copy and paste into SLT the new version, and it should work. It should work. Okay, so just to highlight on the improved version for SLT1. Okay, now once we get the summation D square, and then it calculates for you for the RS, in this case, which is equivalent to 0.254. That means your SLT, the answer will be exactly as our manual calculation. But SLT and manual calculation will differ from SPSS slightly, because when we run for SPSS, the value that we get for RS was only 0.218, right? Not 0.254. So that is expected, because when we run using SPSS, the value will be quite different, right? But the difference is not that much, still within the range. Okay, so now once we get that value, the interpretation is there is a positive and low relationship between, you just change the variable between loyalty and performance. And then when we test for the hypothesis, we set the alpha here, 0.05, and then we select the alternative hypothesis. We are testing for two-tail, so we take the option for two-tail, rho S not equal to 0, and the test statistic is 0.254 because we just present the value for RS, and then the critical value at n equal 9, and then alpha 0.05, the R critical is 0.683. We did the same thing for manual calculation, remember? So when we want to make our decision, if it is based on manual calculation, we compare RS calculated against RS critical. So RS calculated is smaller, therefore fail to reject. Or, but in this case, we cannot derive the significant value, so we just rely on the calculated RS against critical RS, fail to reject. When we fail to reject, what can we conclude? There is no significant relationship between, we just change the variable, loyalty and performance at 0.05 level of significance. And then if you want to present your result, then we can present the result. Where is my result just now? SLT1. Okay. Need to move this one. Okay. If we were to present the result, we can just move a little bit down. And this is how we present the result. I mean, here we have table, whatever the number, result of Spearman row correlation, and then variable. In this case, we have x1 for your for loyalty, and then RS is 0.254. If you have other variable, you can just continue at the bottom. And that means we have series of IV on your DV, right? Okay, that is how if we were to run in SLT1. Okay, so any question? So this SLT1, make sure before you submit your assignment, run your data on SLT1 so that you can check your result. Because to me, when I mark your paper, if the calculation is wrongly done, I just pity my student. Because why? You can check the answer, right? Because last time when I did my study, I don't have that opportunity to check again the SLT because there was no SLT that time. But now you have SLT1, and then it shows you the calculation, it shows you the result. That's why sometimes if the result for your let's say when you run for your chi-square, the value should be, let's say 17.605. I don't expect the value that you calculate to be, let's say, quite different from the actual, because you can check your answer, right? Sometimes maybe you round up too much, because some students, when they calculate for the observed and expected, they round up to integer without any decimal places. Of course, the final result will be different. So if that's the case, since you can check your answer in SLT, I will deduct some point there. Because why? Because you don't take the initiative to check your answer against SLT, right? After that is not that bad. But the worst situation is the calculation is wrong, totally wrong. To me, I just smile to myself. Why? Because we have the opportunity to check before we submit our assignment. Okay, this is a good news for everyone. Good news. Why good news? Because for the midterm exam, the maximum score was only 90. Is it right? Is it from this group or from the other group? The highest score 90 is from this group or from the other group?
This group.
This group.
No, other
No. Yeah, that is lagi teruk lah. Okay kan? Okay, now a good news is I would expect your midterm to be much higher. So what I intend to do, whether you like it or not, this is actually for you, for your own opinion good. I will take part of the opinion of not. I don't consider the midterm exam as 100%, but the midterm exam will be certain percentage. But another percentage will come from your assignment, maybe 6, 7, 8, 9. 6, 7, 8, 9. I mean, from 6, 7, 8, 9, it's not considered, it's not to be used as your assignment. Maybe the last three, maybe the first 6 will be for assignment, will be 30%. But the last 3, maybe 7, 8, 9, I mean, from Spearman row, Pearson correlation, and simple integration, maybe I give certain percentage, maybe 30% or maybe 40%. The rest will be from your midterm. So that will improve your midterm score. Nampak tu Syuhada dah senyum lagi. Because the expectation is most of you, your assignment is high. You get 10, some will get 9.75, some will get 9.5, and some will get 9. But very few get less than 9. So what I intend to do to improve, to help you to improve your midterm score, then from assignment 7, 8, and 9, I will calculate maybe 30%. Right? That will be 30% of the midterm, and then another 70% come from your actual midterm. Therefore, when we add this together, it will increase your score. Agree? Syuhada tak sempat nak jawab, dia ngangguk dulu kan, sebab kalau nak jawab ni kena tekan. I agree, insyaAllah. That is what I can do to help my student, to help our friends here. So because it will be good when we register for courses in addition to getting knowledge and the skill in doing your data analysis later on. But we also want as much as possible to have good grades, right? So that later on, when you share your grade about your performance to your family members, or maybe later on to your kids, then mashallah, my mother Syuhada get A for ERS 5950 statistic. MashaAllah, mother, you are good at your statistic. Right? So because that is recorded, I will be there. Some people put on the dalam bingkai and then place on the wall kan. Jadi good for people to see, oh Masya Allah, my mother is like this. My father, Mahfuz, also perform very well. A, if there is A plus, maybe he will be getting A plus kan. Of course, ketua jabatan sebagai apa ini contoh rakan-rakan lain, kena tunjuk yang terbaik insyaAllah. So after thinking aloud, then that is what I can do to help you. So, but for the final will be the final. That means the final will be 40%. I mean 30% will be our assignment from assignment 1 to assignment 6, and then your midterm exam, another 30%. 30% will come from your assignment 7, 8, 9, and then the actual midterm will be 70%. I will add up. I will consider whether 30% or 40% from the assignment, depending whichever that will improve your grade. But of course, I cannot give too much from the assignment because assignment by right should be assignments, right? So the most that I can consider will be maybe 40% of your midterm grade, midterm score will come from assignment 7, 8, 9, and then 60% come from the actual. I mean, somebody, if let's say that person who get 90, so 90 multiplied by 6, that means will be 54. That means out of 60, he or she will be, get 54. That means, and then let's say for the assignment, if let's say the assignment he or she get 30, so 30 multiplied by multiplied by 0.3, is it right? 0.4. That means the total will be higher, hopefully, insyaAllah. Alright, so Najib pun nampak mengangguk ya. Saya cakap je mengangguk. Kalau orang Perak tu dia kata setuju berbenar lah tu. Setuju berbenar. Bukan tipu-tipunya, insyaAllah. Okay, so that is what we intend to do to help our members to perform better for the midterm exam. But make sure capitalize for your final exam, because final exam will be 40%. And based on experience, most students tends to perform better in the final exam, because we know what is the nature of the exam, right? We have been tuned with the calculation, with all this study strategy that we need to do. Therefore, normally the final exam will be much better, right? Okay, so that take care for our exam, and that also take care for our first example. Any question for the first example? If there's any. Otherwise, we proceed to the second example where we go for sample size more than or equal to 10. But I open for the plenary first, if there's any question. Sharifah, diam je kat situ Sharifah. Nanti nak Sharifah nak ambil assignment balik kan? Maybe representative from section 5 will come to collect the assignment to be distributed to all your friends, and then representative from section 3, representative from PJG group will be coming, so that you can really see. Of course, everyone by right should have already known your score. Assignment 1, assignment 2, assignment 3, 4, and 5, and assignment 6 hopefully I will release by next week. So to look at the actual marking, then you can refer to the distributed assignment that has been marked. So untuk wakil daripada section 5 will be lead by Najib. Itu Najib and Adila. Is it Adila? Adila, and then we have Sharifah plus Latifah there. 4 of our members. Yang grup lain datang seorang-seorang je. But section 5 ni nampak dia punya cohesiveness tu lebih tinggi. So 4 of them coming, 4 of you coming to my house to collect the opinion, which is good, because here is cooperation, teamwork, with teamwork, and we don't have to worry about my experience teaching in UIA. My experience teaching in UIA, they have quota for their grade. Only certain percentage get A, only certain percentage get A minus, only certain percentage get B plus. But let's say now, because the tendency in my class, a lot of students tends to perform. So many people, students get A, but because of the quota, the lower A need to be pushed to be A minus. And then the B minus, the lower B minus need to push to B plus, something like that. But in UPM, you will get whatever grade that you deserve. I mean, if everyone were to get A, I will be happy to assign A to everyone. You will be happy. My head department here, Naziha will also be happy, and everyone will be happy. So we will. But if let's say everyone were to get F, we keep your F for good. I mean, tetap dan berpension. I mean, will not change. So we can change the grade while we work through the semesters. But once the grade is released, then the grade will be fixed and non-negotiable. So if you want to negotiate, then negotiate. But how to negotiate? By participating actively, asking questions, and then either through our live like this or during our WhatsApp. You can ask, because I will be happy to respond to questions rather than when I open WhatsApp, no message. So that means if there's no message, that means my expectation is my students are clear on whatever that we have discussed. That means you don't have any question to ask. It's okay. But if you have any question, please post in our WhatsApp group so that I will try to respond. Or maybe some of our friends can also respond to your concern, inshallah. Okay. So any question, Syuhada?
Prof.
Syuhada dah nak share dah ni, dah semangat ni. Okay, Syuhada.
I want to ask, in
Yeah.
example 1, the sample size is less than 10.
Yeah.
So why we still need to calculate T?
No. If your sample size is less than 10, remember in testing for the hypothesis, step number 1, state HOHA. Step number 2, we don't need to calculate any additional statistic. We just report RS. Earlier, when we do our calculation for question number 1, where we calculate the coefficient, we get the value for RS to be 0.254, is that right? So in step number 2, if your sample size is less than 10, we just say RS equal 0.254. No need to do the calculation anymore. Not to calculate T. Yeah.
Because Prof state in the notes of calculate the T, that's why I asked.
Itu yang lama ke yang baru?
The latest one, Prof.
Huh?
I print the latest one this morning.
Oh yeah.
Still has T test, T statistic.
Yeah, gitu. Okay, let's go back to the opinion. Let me open the notes. Let me open the notes and make sure that we are sharing the same thing. If there is any mistake, then of course we need to change. Okay, these are assignment 1. Assignment 1. Which particular slide was that? Syuhada?
Example 1. Example 1.
Okay, this is example 1.
At the number B calculate test.
That was the old version.
The version. I see.
Maybe did I send you the old version? Because the new version should be like this. If you open, let me open the screen for this one.
Oh, betul. Saya print yang pagi tadi juga.
Oh, so that means maybe I send you the old one. I will resend. By right, it should be. But it should be like this. Right. Step number 3. Question number 3, test the hypothesis on relationship between the two variables at 0.05 level of significance. So I don't put ABC. ABC was the old version. So step number 1, state null and alternative hypothesis. This will be the new one. And then number 2, report RS, which is RS equal 0.254. Step number 3, determine critical value. And then step number 4 will be your decision, and finally conclusion. I mean, I share you still the old one. Maybe I need to come to check, and I will send you the new version. Sorry for that. So bagus lah Syuhada, you highlightkan ke tidak tu? To me, my conscience is clear. I have already shared the new version of the note, but in reality, I share you the old one. Right? Okay, I will resubmit you. I will resend the notes after the class, inshallah.
Okay, thank you, Prof.
Okay, welcome. Okay, if there's no question, then we go for the second example here. The second example is the case for sample size more than or equal to 10. Okay, so the example here, data solicited or data collected from a randomly selected sample were used to measure relationship between working environment A working environment is IV or DV in this case? Working environment is IV because the
IV.
first level will be the IV. So working environment is IV, and work commitment, the DV. EDA reveals that the data for commitment did not meet the assumption of normality. That means this is the clue that you need to apply for Spearman rule correlation, because data for one of the variable which happen to be the DV, work commitment, the distribution is not normal. Therefore, we need to apply the RS. Even though the question says calculate the appropriate correlation coefficient, but we are not going to calculate R, but instead we will calculate RS. Okay, question number 1, we calculate RS. Question number 2, describe the nature of relationship. Question number 3, test the hypothesis on the relationship at 0.05 level of significance. The data given, X will be the working environment score, and then Y will be the work commitment score. All right, so now based on this data, so in order to respond to this example number 2, what we need to do will be, we need to calculate the RS, right? In order to calculate RS, this will be the data set X and Y. So we need to rank X, we need to rank Y. That means Rx, Ry. And then from there we calculate D. How to calculate D? Rx minus Ry. And then finally we calculate D square. And what we want is summation D square. So summation D square for this data set is 242.5. I mean, we need to spell out step by step until we get the summation D square. Once we get summation D square, then we can calculate for our RS, where RS equal 1. Okay, just a gentle reminder here. Based on experience, some students, when they are so excited, I mean, they are so engrossed with their formula, what happened was the formula become 1 minus 6 summation D square, the whole thing divided by n square minus 1, which is not right, is it right? Because 1 here is separate, 1 minus, and then we have summation D square, 6 summation D square divided by n square minus 1. So make sure when you copy the formula correctly. Otherwise, when you combine 1 minus 6 summation D square, the whole thing divided by n square minus 1, then the formula is totally different. Okay, this is the formula to calculate. So what is it that we need to know? We need to know what is summation D square. 1 is a constant, 6 is also constant. So the variable are D square and n, is that right? So n in this case will be, what is n in this case? 12, is that right? 12 cases, that means n equal 12. Therefore, so 1 minus, we plug in the value, 6 multiplied by summation D square is 242.5 divided by n, which is 12, and then 12 square minus 1, which is equivalent to 1 minus, we maintain the 1, don't associate 1 with the numerator. So 1 minus 6 multiplied by 242.5 is 1,455 divided by 1,716. How to get 1,716? 12 multiplied by 144 minus 1 will be 143, is that right? So 143 multiplied by 12 will be 1,716, which is equivalent to 1 minus, what is, when you solve for this fraction, what you get is 0.848. I mean, when you do your calculation, the least will be 3 decimal places. Don't round up to only 1 or maybe sometimes integer. So round up to at least 3 decimal places. And when you calculate for this, the value for your RS is 0.152. That will be your RS. That will be the answer for your question number 1. Very straightforward. But the tricky part is you need to rank for your X, rank for your Y, calculate D square, and what we want is summation D square. Once you get that, you can plug in the value into your equation, then you can solve for your RS. That take care for question number 1. Question number 2, what can we explain when RS equal 0.152? I mean, we are saying that there is a positive. Why positive? Because there is no indication of the sign, is that right? No sign means positive. Therefore, there is a positive. And what about the strength? 0.152, according to Guilford rule of thumb, is less than 0.2. When it is less than 0.2, that means it is considered as negligible relationship. Therefore, we can say there is a positive and negligible relationship between working environment and work commitment. That will be answer for question number 2. So by right, your assignment shouldn't be thick. But what I observe, some not many, but few of the students sometimes very thick assignment. And the worst scenario was the score was low. So that means we don't really know what is it that we need to respond to the question. So in this case, if the question says calculate RS, so we just calculate and then show the step, and then question number 2 describe, and we can just describe like that. And then step number 3, question number 3, we want to test the hypothesis on the relationship at 0.05 level of significance. So when we read through the step question, it doesn't indicate directions, right? Therefore, it calls for two-tail. When it is two-tail, then step number 1, we state the null and alternative hypothesis. HO rho S equals 0 will always be as such. The alternative hypothesis for two-tail, rho S not equal to 0. That will be step number 1. Step number 2, we set alpha based on the question, alpha 0.05, therefore alpha equal 0.05. Oh, no, this is manual calculation. Yeah, sorry. For manual calculation, sample size more than or equal to 10, therefore we need to calculate our t statistic. So t equal RS minus rho S divided by square root of 1 minus RS square divided by n minus 2, which is equivalent to, in this case, RS is 0.152, rho S is 0, so 0.152 minus 0 divided by square root of 1 minus RS square. So RS is 0.152, square that value, divided by n is 12, and then minus 2. So you just plug in the value accordingly, and then solve for this, which is equivalent to 0.152 minus 0 will be 0.152. When you solve for the denominator, 1 minus 0.152 square divided by 10, and then get the square root, you get to be square root 0.09769, which is equivalent to 0.152 divided by, when you get square root of this value, is 0.31255. And when you divide these two, what you get is 0.4863. 0.4863. And that will be your RS. And that will be the second step in your testing for hypothesis. Our t value is 0.4863. If I were to ask you, this value for t, 0.4863, is considered to be big or small, large or small? The value for the t is, if it is 0.48,
Bigger.
is it big or small?
Big.
Yeah?
Big.
Big. Adila kata big. But remember, Adila, your t ranges between minus infinity to plus infinity. That means the value for your t can be from the high, whatever the lowest value, minus, to whatever the highest value, plus. So if it is less than 1, it is considered to be too small, is that right?
Okay, noted.
Because the range is not between minus 1 to plus 1, but the value for your t ranges between minus infinity to plus infinity. Why I ask you whether it is big or small? Okay, the issue is, if the t that you calculate is big, there is high tendency for you to reject the null hypothesis. But if your t is small, like this, if it is small, less than 1, or maybe 1 point something, or even 2 point something, still considered to be small, the tendency will be you fail to reject the null hypothesis. That is the reason why I ask you whether the t value is big or small. So in this case, why small? Because your t ranges between minus infinity to plus infinity. Therefore, a value that is less than 1 is considered to be too small. Okay, I mean, our expectation is when we proceed to step number 4, where we want to make our decision, naturally, we should fail to reject the null hypothesis. We don't reject, but fail to reject. Because why? Because your t calculated is smaller than t critical. Okay, so that is step number 2. Any question about step number 2? If you go step by step, but make sure if you have the square, make sure square the value. If it is square root, make sure square root the value so that the answer that you get is correct. But if it is in assignment, you don't have to worry that much because you can compare your answer against SLT. But if it is your exam, of course, you need to be careful. Otherwise, maybe you get the answer and what should I say? If you go the wrong way, when you look, because our exam will be objectives, right? That means if you go the right way, you get the answer. The answer is there. If you go the wrong way, the answer is also there. So that means not necessarily when you do your calculation, when your calculation is incorrect, but the answer is there. So not necessarily it's correct, because I will try as much as possible. Whatever route, if you go to A, you get answer for A. If you go through B, the procedure, the answer is also there. If you go through route C, the answer is also there. But I've got to go extra work. That's why I have to prepare the exam much earlier, right? Okay, so make sure do your calculation perfectly. In this case, you have to be very careful, because why? For sit in, the step that you do, even though your final answer, the final answer is incorrect, but you still get some marks because of your step. But for our final exam, because our exam, you don't show the calculation, you just tick the answer. Therefore, if let's say the answer is the correct answer is, let's say, 4 points, wrong answer will be 0. So that means you will not get, let's say, 1 or 2 or 3, but either you get 0 or 4. Right? So please be careful in your calculation. So what is important here will be, you need to have enough practice so that you can see the flow of the step, and then the calculation will be done smoothly. All right, smoothly. Okay, so no questions here, right? So T is 0.4862. Is it big or small? It is comparatively very small, right? Because less than 1. So step number 3, we want to determine critical value. In order to determine the critical value in this particular case, since this is 2 tail, therefore alpha divided by 2. So if you go to your T table, alpha divided by 2 is 0.025, and degree of freedom is n minus 2. So 12 minus 2 will be 10. So if you refer to the table, okay, please open your table. Make sure the critical value at 0.05, at 0.025, at 10 degree of freedom is 2.228. Everyone, do you get that value? Okay, no response? Do you get that value?
Yes,
Okay.
yes, Prof, yes.
Otherwise saya cakap seorang je. Nah, tapi tak, kalau saya cakap seorang pun, nanti bila saya sharekan the video, then you can hear kan. Okay, so everyone, you have derive the critical value at 0.025, degree of freedom is 10, the critical value for the T is 2.228. So as what we expect, when we want to make our decision, we just compare T calculated, which is 0.4863 against critical value 2.228. Our calculated T is smaller than critical T, right? Therefore, fail to reject HO. When we fail to reject HO, what can we conclude? The conclusion here will be there is no significant relationship between working environment and work commitment at 0.05 level of significance. So, but what we can see here is basically your working environment doesn't really lead towards higher work commitment. I mean, in this case, whatever the working environment is is as good as for you to commit to the organization, working commitment. So that will be our 5-step procedure when we go for the sample size more than or equal to 10, whereby in step number 2, we calculate our T value, and then step number 3, we determine our T critical, and then from there, we proceed to the decision and finally conclusion. Right? So that means I will share. If I were to forget Syuhada, please remind me. Syuhada will be the one to remind me. But if I were to send to you, still ABC, not 1, 2, 3. I mean, because still will be the old version. So I will do it immediately after the class, inshallah. So any question about the 5-step procedure in testing for the hypothesis for manual calculation? Clear, is it right? But what is important here will be practice, practice, practice. Don't be too excited to work on your assignment. Maybe you practice for today is Thursday, is it right? So Thursday, tomorrow will be New Year, is it right? Tahun baru, holiday. All right, so you can have another day for practice, and then maybe on Saturday you can start doing your assignment. And then by doing this, so that means you are testing your understanding, whether you have already understood Otherwise, if you just work on your assignment and then refer to the notes to complete your assignment 7, you don't learn actually. You don't learn. You just follow. I just follow step 1, step 2, step 3, but it is not in your memory. But what we want, when we say you understood, that means it is in your memory. That means you can recall what are the steps, what are the things that we need to do in order to work through the calculation for RS, and then to interpret your RS, and then to test the hypothesis on your RS, right? But if let's say if you were to sit somewhere and try to recall, nothing that you can retrieve from the memory, that means you don't learn. So that's why my advice is, don't be too excited to work on your assignment. Practice maybe at least 2 or 3 times, and then only you work on your assignment. When you work on your assignment, please just refer to your formula sheet, because during exam formula sheet, you can refer to, you can open your formula sheet, but you cannot open by right. I'm talking about by right. You shouldn't open your notes, right? So make sure if you have practice, you have enough practice, then the information is already in the memory, so it's just for you to implement. It's for you to execute, right? Not to, oh, what is step number 1? What is step number 2? You already have that step in your memory. Okay, if there is no question, then how to run this in SPSS? Okay, now let's go for SPSS. We run for this data set. Oh, ada lagi. Nak masuk. Okay, let me copy the data set first. In this case, we have 12 cases. Copy. Okay, now let's open our SPSS. Open SPSS. Okay, SPSS. Where is SPSS? Oh, here. Okay, and then we can just remove this. You don't have to open a new data editor. You just highlight X and Y, and then delete, and then paste the data. In my case, I can paste because I have the Word document. Okay, now what you need to do, first of all, define the 2 variables as X and Y. X, where is X? X and Y. What is X? X is working environment. Working environment scores. And then what is Y? Y is work commitment score. Okay, we have these 2 variables. Okay, define the 2 variables, X and Y, and assign the label. Once you have assigned the label and name, click on data view, and then just enter this data set. We have 10 cases. Oh, wait. By right, we should have 12 cases. Let me open the data again. Oh, kat bawah ni ada lagi ni. Oh, 716 tu. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12. So let me try to copy. Spaces. Right. Wait, how come bila copy dia jadi 1, 2, 3, 4, 5, 6, 7, 10. Hilang hilang 2. Macam mana dia hilang 2? 6, 15, 7, 12, 7, 12. Yang last datanya apa dia? Actual data 7, 12. Oh, we have another 2 here. 2 cases. 6, 14, and then 7, 16. So we just continue there. Where is my mouse? Okay, let me remove this, all this, yeah. Remove. Okay, so we'll just continue. 6, 6 and 7, and then 14 and 16. Silap ni. Edit. (6) and 14, and then 7 and 16. Okay, that are the 12 data data for the 12 cases. 6:15, 5:34, 8:11, 4:09, and finally 7:16. Okay, check the data, make sure it is correct. Okay, let me check the data. 6:15, 5:34, 8:11, 4:09, 9:17, 6:12, and then 7:13, and then 5:23, 4:11, 7:12, 6:14, 7:16. Okay, this is right. Okay, now this is our data set. Okay, once we have this data entered into SPSS, so to run the analysis, the same procedure that we did earlier, click on Analyze, click on Correlate, and then click on the right for bivariate, and then enter the two variable X and Y into the variable box on the right, and then we tick the Spearman because we have already ticked earlier, and then it is two-tail, and then once done, simply click OK. When we click OK, this will be our result here. So let me open to the SPSS viewer. The result will be here. Right? Okay, this is our result. So what we get is RS for working environment and work commitment. What should be the value? RS equal 0.134. When we did our calculation was 0.1. When we did our manual calculation, what was the value? Remember? When we did our calculation, the value was 0.152, is it right? 0.152. But when we run for SPSS, the result is 0.134. And then significant value for the RS is 0.678. Very nice number again, 0.678. Okay, now, based on this output, we know that this is output for Spearman row. Why Spearman row? In the first place, it indicates here in the title, non-parametric correlation, and then it also indicates in the table Spearman row, and then you know that this is Spearman, not Pearson product moment correlation. Okay, based on this, okay, the possible question to be asked, question number 1, Sandra. Okay, Sandra, question number 1, what are the two variables in this analysis? What are the two variables in this analysis?
Work environment and work commitment.
Working environment and work commitment. Okay, question number 2. Question number 2. Let me ask somebody. Question number 2. Let me open the plenary here. Oh, okay. Question number 2. Wang Weng Peng. Question number 2. What should be the scale of measurement for working environment? What should be the scale of measurement? Wang Wenpeng?
Yes.
What should be the scale of measurement? What should be the scale of measurement for working environment? Should it be nominal? Okay. Is it nominal, ordinal, interval, or ratio? Okay, in the first place, ask the first question. Numeric or alphanumeric? The value that for this variable working environment, numeric or alphanumeric?
No.
It's a numeric, is that right? Because when we enter the score, 6, 8, 9, numeric, right? Is that right? When it is numeric, if it is numeric, it can be either interval or ratio, cannot be nominal or ordinal. So now, should it be nominal? Should it be interval or ratio? So in order to ask for that, we ask what is 0? So 0 for working environment means something or nothing. Means something, right? When 0 means something, that is interval scale. Interval scale. Sini tak boleh. Tengok. Tu tapi student atuk kat situ tu. Nampak tu. Student atuk. Nampak? Ramai student atuk kat depan. Okay, okay. So when it is numeric and 0 means something, therefore, scale for working environment is interval. Okay, the next question. Zhao Zhu, what should be the scale of measurement for work commitment? Nominal, ordinal, interval, or ratio?
Also internal.
Yeah, also interval because it is numeric where 0 means something. Okay, that would be
Something.
question number 2. Question number 3, Najib, what would be, if we were to test, okay, question number 3, the one, A, B, C, D, E. Okay, the question number 2, if we were to test this hypothesis at alpha 0.05, at alpha equal 0.05, what would be the appropriate null and alternative hypothesis? Najib? HO will be
HO rho S equals
rho
0.
S equals 0. Alternative hypothesis, this is one tail or two tail?
This one two tail.
How do you know that this is two tail?
Because there is no direction.
No, in this case, because when you go, I need power. I need to connect to the power. Okay, in this case, we need to refer to the output. Where in the output that indicate two tail?
The significant
Significant
value.
within bracket two tail, is that right? That means the output itself indicate this is two tail, because if it is one tail, I should have select the option for one tail. All right, so in this case, should two tail. Therefore, HA will be rho S.
Rho S not equal 0.
That's right. I mean, that will be question 2A. Question 2A. Okay, now we proceed to question 2B. Okay, for question 2B, okay, Sharifah tunggu. Nampak tu kipas kat atas, tapi kipas tu tak bergerak sebab dia pasang aircon kan. Okay, so Sharifah, apa ni question number 2? What would be alpha? What would be the alpha to be set in this analysis?
0.05 divide 2.
What it should be alpha? What is alpha? We alpha divided by 2 when we want to determine critical value in manual calculation. This one nothing to do with manual calculation. So in this case, we are testing for using SPSS, yeah, right? So what should be alpha? Remember, we mentioned if nothing mentioned about alpha, what should be alpha? If nothing mentioned about alpha, what should be alpha? 0.05. I mean, alpha is 0.05. Unless otherwise stated. I mean, in this case, we cannot see from the output. But if let's say the question says, test the hypothesis at 0.01 or test the hypothesis at 0.05, that means we know 0.01 or 0.05. But if nothing mentioned, then it is understood, Sharifah, alpha is 0.05. Okay, that is 2A. 2B, Mounting, question 2C, what would be the value for the test statistic? What would be the value for the test statistic? Mounting, or Irwan kat atas pun dah cek ready. Okay, lepas ni kita go for Irwan. So Mounting, what should be? I can see just your head plus your eyes, part of your eyes. I can see the whole of you. Okay, so Mounting, you want to respond? What should be the value for the test statistic question 2C?
T 0.218.
0.218. That was the example 1. This is example 2. Example 2.
0.134.
Okay. If you write as 0.134, that is partial answer. A complete answer will be when the question asks what will be the value for the test statistic. The complete answer will be RS equal 0.134. If you just write 0.134, it can be F, it can be T, it can be chi-square, it can be anything, right? But actually, this is your RS. So, in question 2C, the question says, what would be the value for the test statistic? The complete answer will be RS equal 0.134. Okay, that will be question 2C. question 2D, Erwan. What would be your decision and justify your answer? What would be your decision and justify your answer?
Okay, the decision is fail to reject.
Okay, why? The
Because
justification?
the significant value is more than alpha. It's greater
The
than
complete
alpha.
answer will be significant RS, or just simply the p-value within bracket 0.678 bigger than alpha 0.05 within bracket. I mean, that will be a complete answer. Because if you just simply say the significant value is bigger than alpha, what is the significant value? Which one? Is it 0.134 or is it 0.678 or is it 12? Or is it 1? It can be anything, right? So that means you need to be specific. So the answer for question 2D will be, since significant RS within bracket 0.678 bigger than alpha within bracket 0.05, therefore fail to reject HO. When we fail to reject HO in question 2D, question 2E, question 2E, Aiman, where is Aiman? Oh, Aiman, tadi sudah ya. Maybe Nishantini. Nishantini, you want to respond to the last question? What would be your conclusion? Nishantini, are you there? I can see your name. Okay. Please repeat.
There is no significant relationship between working environment and working commitment scores at 0.5 level of significance.
That's right. I mean, since we fail to reject, the conclusion is there is no significant relationship between working environment and work commitment at 0.05 level of significance. Now, that will be how we respond to the question. See, very straightforward. It's very objective. But what's important will be we need to be clear on the step. We need to be clear on what should be the decision criteria. And once we have made our decision, we should be clear what should be our conclusion. Either there is significant relationship or no significant relationship. But don't say there is significant difference or no significant difference, because when we go for the testing for Spearman row, that means our concern is on relationships, right? Because some students, they just write at the end, there is no significant difference. That means when the keyword is different, I mean, it's wrong. It must be there is no significant relationship between identify the variable, which are working environment and work commitment at 0.05 level of significance. That is if you were to use SPSS. Okay, now finally, how to run this in SLT. Okay, let's go to SLT. Copy your data first. Copy your X and Y from SPSS, copy, Control C for you to copy, and then now go to your SPSS, go to SLT. Go to SLT, the last thing to be discussed. When you go to SLT, right, and then, where is the, okay, when you go to SLT, then what you need to do will be reset, and then paste. When you paste your X and Y, automatically it calculates for you the Rx, Ry, D and D square. And what we want is summation D square, is it right? In order to get summation D square, we look at down here, summation D square is 242.5. I mean, you can check your calculation. And then when you calculate for your Rs, the value is 0.152. Identical to our manual calculation, it is 0.152. What can we say when, I mean, this is your question number 1. I mean, the detail of the calculation is based on this value here, and then you can check your answer. And then how can we interpret the nature of relationship? Then we say there is a positive and still negligible relationship between working environment and work commitment. That will be the interpretation for the nature of relationship. And if we are testing for the hypothesis, then we set alpha 0.05, and then we select the HA. In this case, we go for two-tail, rho S not equal to 0, and RS will be 0.152. Oh no, this one is because we are using this one. So we go for the second option, under 16, because this one, the sample size is more than or equal to 10. So we go for option 16. So paste here. When you paste here, so you get the same thing, where your summation D square is 242.5, and then our 6 summation d square is 6 multiplied by 242.5 is 1455.000. N square minus 1 is 143, and then n multiplied by n square minus 1 is 1716, and then the whole thing here is 0.848. Therefore, RS equal 1 minus 0.848, which is equivalent to 0.152. I mean, it showed you the detail of the calculation, right? The detail of the calculation. I mean, you can check your answer. And then what can we explain? In terms of the natural relationship, there is a positive because 0.152 is positive. And what about the strength? Negligible relationship between working environment and work commitment. And then if we are testing for the hypothesis at 0.05, so set alpha 0.05, and then select the HA for two-tail, and then it calculates for you the T equal 0.487, significant T 0.637. Earlier, when we go for SPSS, the value for RS was 0.134, is that right? And the significant value was 0.678. But in this case, is our calculated statistic is 0.152 RS, and then the T is 0.487, significant T is 0.637. That means slightly different from our SPSS. But if you are using manual calculation, this will be what we need to respond. And but also you are given a significant T to make decision based on SPSS. So now, in step number 3, critical value at degree of freedom equal 10, alpha 0.025, because with alpha divided by 2, the critical T is 2.228, two-tail. And then decision, since your T calculated 0.487 smaller than your T critical 2.228, therefore fail to reject the null hypothesis. Or if you are using SPSS, we just compare significant T, which is in this case 0.637, smaller, bigger than alpha, therefore also fail to reject. When we fail to reject, what can we conclude? There is no significant relationship between working environment and work commitment at 0.05 level of significance. We don't see 0.025 because 0.025 to determine the critical value for manual calculation. But we just set our alpha, which is in this case 0.05. Therefore, the conclusion is there is no significant relationship between working environment and work commitment at 0.05 level of significance. Right? And then how to present this in your thesis or in your project paper? We can just present like what we have presented earlier, the variable, RS, and the P value. Okay, that is basically what we need to explain for your Spearman row correlation. Okay, now we have gone through for manual calculation, we have gone through for the SPSS, we also have gone through for SLT for 2 examples. The first example, n less than 10, and then the second example, n more than or equal to 10. So we have gone for both. So that complete our discussion for Spearman row correlation. Unless if you have any question, then I'll try to respond. Otherwise, we call for the day at what time now? 12:07, which is exceeding by 7 minutes, 7 minutes, because we end by 12. So it's 12:07. But if you have any question, then feel free to ask. If, yeah. Okay, Najib.
Just to make my mind correct, for the last assignment for chi-square, we use the participation cap, right? Either with gender or sector, right?
Okay, you can use because remember the requirement is IV and DV must be either in nominal or ordinal, but at least one of the variable is nominal scale. So since participation cap is already ordinal, therefore your IV should be one that is nominal. Therefore you can use gender, you can use sector, or, any of this variable will do.
Right.
So
for this,
your paper up in Najib, you get 100 up in 10 out of 10. So alhamdulillah, congratulations.
Thank you, Prof. Just to make myself for the assignment 7, there are four IV that we can choose, right, Prof?
Yeah, choose only one. Ini macam nak kahwin 4 je ni. Of course, you can go for 4, but try one first. Okay, so in this case, you choose either. I mean, to make life easier, we can choose among the computed the variable that comprises of an item where we have already computed the variable, and then you can use one of the variable. You can use either or attitude, subjective norm, perceived behavior control, and environment as your IV, and make sure the DV will be participation. Masya Allah, I've given you the answer. Masya Allah. Pandai apa ini Najib joget.
Kalau tidak saya dia bermain fikiran. Betul ke salah? Betul ke salah?
Betul lah tadi tu. But make sure use your computed variable, not the cat. Not the cat. The computed variable. If it is attitude, will be attitude, not attitude cat. If it is apa ini subjective norm, not subjective norm, not norm underscore cat. Okay. Okay, that answer a selection of your variables. So that remember, question apa ini assignment 7, 8, and 9 will be part of your midterm exam. So make sure you apa ini you perform highest possible. Any other question?
Yes, Prof.
Yeah. Who is that?
Adilas.
Yeah.
I realized
three suit apa ini three suit three piece. Three piece. Okay. Teruskan.
Soalan saya, SLT tadi waktu kita test, when we test for less than 10, the result presentation doesn't have P, while this one, the P is there. When we are doing SPSS, the P is in both less than 10 and more than 10 when we test it.
Yeah. So that means when you run for your SPSS, that means for the last question where you have selected one of the 4 variable on participation, then you report the value regardless of whether your sample size is less than or more than 10. You need also have your P value, because we cannot have the P value for manual calculation. Remember, manual calculation we just have the RS, but without the P. Even some student in assignment 6 for chi-square, when they calculate for the chi-square value, and then the next column is significant chi-square. You don't have the significant chi-square unless if you go to SPSS. So for manual calculation, you don't have the significant value, right? So for the last question, regardless of the sample size, you will be given the P, right? So you use that P in order to decide whether to reject or fail to reject the null hypothesis. Does that answer your question, Adilas?
Yes, I understand that, but the SLT and the SPSS, when we test for less than 10 before, just now, the SLT result presentation doesn't have P. It's only indicate RS2 only.
Yeah, because currently we don't present the P value. So they mean, but we just use the manual calculation to make our decision. I mean, we compare RS calculated against RS critical.
Okay, thank you.
Right, good. Okay, others?
Prof.
Oh yeah.
I want to ask.
Yeah.
For presenting result presentation too, we only show the one variable only.
Oh yeah, only one variable because we are selecting only one variable. But in reality, for your thesis, you have several variables. That's why for your table you have x1, x2, x3, x4. That means if we were to run for this data set for assignment 1, that means we will have attitude, subjective norm, perceived behavior control, and environment as your factors, and then you have the RS and the P value. But in our assignment, we choose only one, is that right? That means we have that. That means you give one a space a little bit, and that will be good enough for your table. So make sure present the table accordingly, according to the sequence of your question, not to be at the end, not to be at depending on what the question asks, right? So that, and then don't mix your answer with the SPSS output. SPSS output will be your appendix. Appendix will be at the back. Right? So hopefully from assignment 7 until 9, I will see more systematic presentation of the assignment response or answers to assignment 7, 8, and 9. Otherwise, unnecessarily I have got output in between and I have to flip over a few pages, then only I have the answer for the next question, which is actually not good. It doesn't show that because that is not part of the answer. That is just to report the result for your SPSS. And then when you run for your SPSS, if the question doesn't ask for test for assumption normality, you don't have to test for the assumption normality, right? And I mean, you don't have to present the result. Otherwise, tick assignment. Maybe some others they just have maybe 4 or 5 pages. Some may go up to 10 pages, which is wastage, right? So be selective in presenting in your appendix, right? Okay. Any other question? Otherwise, thank you very much. Have a nice weekend and Happy New Year. This Friday. Tomorrow will be New Year's, yeah, right? And with the New Year, then we set a new target for our performance in ERS 5950. That was me in year 2020, but now this is me in year 2021. So I want to show to the whole world what is me in 2021. And you can see my performance in my final exam. And this final exam will be 40% of the total, inshallah. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome.
Thank you, Prof.
Sama, thanks a lot. Okay, bye.
Thank you,
Yeah,
Prof.
sorry.